Okay, you can see that we had our breadboard circuit, and here's the schematic for the Scrubberbot. So what we're going to do is we're going to transfer over all the components from the breadboard to this PCB prototype board. So I'm going to first take off this battery snap connector. And I want to determine where I want to put the battery snap connector for the power supply on this PCB prototype board. Here's a look at the back end of it and the front end. You can use whatever type of PCB you'd like. I'm just choosing the through holes for where I want the power supply to be. I'm kind of just doing this on the fly, so as I go I just pick and choose where I want my components to be on the PCB. You can choose however you want to orient your components. Just be sure you're following the schematic for your Scrubberbot to work properly. Notice that the contact traces are separate from each other here. We don't want the power supply terminals connected directly together. So you could see on the PCB board that the contacts are together, where you see kind of the copperish, kind of goldish color, where the holes are in line and connected to each other. First, I want to trim the wires of the battery snap connector. I don't need it too long. I'm just making sure not to trim off too much. Now I'll just strip the ends of the wires I just cut so I can expose the ends of the wires to be able to solder it to the PCB board. Now this just needs to be soldered. I'll just trim the excess wire off. I'll bend them over a little bit in order to cut them off with my little wire snips. Here's the slide switch. It's just a 3-prong slide switch, or 3-terminal slide switch. You can choose wherever you want to place your switch in your circuit for your PCB. Remember just to follow the schematic that I've provided. I've placed the 3 pins where the left pin is on column 2 of row I. The center pin is under column 3 of row I, and the right pin is under column 4 of row I here. Now I'll just need to solder the switch to the PCB board. And now I'll trim the excess wire from the terminals of the slide switch. Now I need to make a jumper wire for the switch to power. I just need to cut it to size. I'll bend the ends over in order to stick through the through holes of the PCB. The jumper wire will go from center terminal of the switch to the positive supply, just like we did for the breadboard or on the breadboard. Now I've cut the jumper wire to size. I'll place the jumper wire where I need it to go, following the schematic for the Scrubberbot. Now I'll just bend over the wire that's sticking out from underneath to hold it in place while I solder it. And next I'll solder the jumper wire to the PCB. And now I'll trim the excess. Okay, at this point I had to start again because my camera had stopped recording. So I'm going to explain what's been done to this point that wasn't recorded on camera. I have the complete breadboard circuit to the left and what's been done on the PCB to this point on the right. So far I've got the battery snap connector soldered to the PCB. I've got the jumper wire from the positive power supply to center pin of the slide switch. I've got the 1K ohm resistor from the right pin of the switch to the anode or positive lead of the LED. And I have the cathode or the negative terminal of the LED connected to ground. I'm just tracing through with my orange pointer stick here to show you the path of the circuit I've done so far that wasn't captured on camera, matching the traces from the breadboard to the PCB. Again, refer to the schematic. It's pretty much set up the same way as it shows on the schematic that's provided. Here's a closer look at the PCB thus far. The positive supplied to column 1 of row F of the PCB. And I have the jumper wire from column 1, row J, to column 3 of row J. The 3-pin slide switch takes up columns 2, 3, and 4 of row I. The far right pin of the switch is in column 4, row I. The resistor and anode of the LED are connected along column 4. And the cathode of the LED is connected to ground or negative of the power supply. At this point, we can test that our LED is working in our circuit just by adding the battery to the battery snap connector, and then we can just flip the switch to see the LED turn on. Now we want to move on to our first diode in the circuit. I think I'm going to place it in column 6 of my PCB, but you can choose wherever you want to place yours, or you can follow along exactly as I'm doing mine. Just be sure that you're following the schematic that's provided. The diodes will be placed in reverse bias orientation. This means that we'll place the diode's anode terminal to ground or to the negative supply. So if you look at the diode, you can see that the gray strip here, that it indicates the diode's cathode end, so that's the negative end of the diode. I've placed the cathode in column 7 of row F. The anode is placed in column 10 of row F. This position will be changed later as I proceed. You can set your placement of components however you wish. Just make sure you follow the schematic that's given to you for the Scrubberbot. I'm going to use these pins for the motors to hook up using Dupont connectors. It'll make things much easier when we need to connect and disconnect or change the rotation of the DC motors that we'll add to the circuit later. I just need 2 of the pins. I'm using red here because I wanted to match the color of the red wires for one of the motors I have. They were already on there, so I thought it'd be nice to match the colors. And later I'll use blue pins for the blue wired motor that I have. You can use any color that you'd like. I've placed the pins in columns 8 and 9 of row F here. At this point, I've decided to move the diode up to row H, columns 7 and 10. Again, I'm just kind of winging it here. I'm sticking to the schematic, but I'm just rearranging things to fit the way I would like it to on my PCB board. I'll need a jumper wire later from the pin of the switch connected to the resistor over to the cathode of the diode. Now I'll prepare to place in the second diode. As I mentioned before, I'm going to pair up this diode with the blue pins for my blue wired motor. Again, I just wanted to match up the colors that I had for the wires. And again, I just need 2 of them. I've placed the pins in columns 8 and 9 of row A. This diode will be placed in columns 7 and 10 of row C. Note the cathode orientation of both diodes. I'll put in jumper wires next to connect the components. At this point, I've decided to move the pins over to columns 9 and 10. This will make installing jumper wires easier for my setup. Once the jumper wires are in, the highlighted orange that's shown on your screen is what's been done so far. I'm tracing out where ground is, the bottom orange highlighted line on your screen, in the schematic shown above. Now I'm taking the pins out for now, and I'll show you a trick to solder them straight on the PCB later. For now, I'm going to solder the diodes. I'll just have to bend the leads over to keep them in place. I'll put them on my helping hands, and then I'll get to soldering those. And now I just need to trim the excess wires. To solder the pins perfectly on the PCB, we'll use the help of a breadboard. So what I'll do is I'll place the pins on the breadboard, allowing enough room for the other components on the PCB to be clear of the breadboard, since I have to place it upside down in order to solder from the bottom of the breadboard, or from the bottom of the PCB. I also need to make sure the shorter ends of the pins are facing up on the breadboard. This will hold everything nice and straight and where I need it to be. All I'm doing here is moving the pins on the breadboard because the switch was in my way. Now I'm double checking that my red and blue pins will go where I wanted them on the PCB. The trick of using a breadboard to solder pins on the PCB makes things much easier, and it makes things look much better. Okay, now it's time for the jumper wires to complete the circuit. Again, I provided the schematic on your screen here, and the orange highlighted parts of the schematic are what we have currently done. This one is to connect from the switch to the first diode in parallel. That's D1 in the schematic. This jumper connects the diode D1 to the first motor M1 in the schematic, the red pins for my red wired motor. These red jumper wire connections are essentially the top orange wire, or the positive supply, in the schematic. Now I'll just need to solder the jumper wires in. This blue jumper wire represents the connection from the diodes D1 to D2 in the schematic. Again, the top orange highlighted line in the schematic that I'll show here next. This next blue jumper wire will connect the cathode of D2 to the second motor M2 in the schematic that I'll show next. It'll represent the blue pins for my blue wired motor. Now I just need to bend the wires over, that way I can solder it to the board. This green jumper wire will be the reference wire or ground wire from diodes D1 to D2, the bottom orange highlighted wire in the schematic shown next. From here, we'll run a jumper wire to ground. I'll remove this jumper wire to ground for now so that I could solder the other wire. I'll take note where the jumper wire is in relation to my PCB. One side of the jumper wire connects at column 10 of row D. The other end of the jumper wire connects at column 1 of row D. Now I'm just going to trim some of this wire off this motor. And then I'll strip the ends, and then I'm going to attach a Dupont connector to them. What the Dupont connectors allow is you to be able to connect and disconnect the motors easily. This is a pin for a Dupont connector. We'll attach one to each end of the wires from the motor. If you need a little bit more detailed commentary on these Dupont connectors, please check out the video at the end of the blog page for the Scrubberbot project, where I explain further on how to use these Dupont connectors and how to attach them, or I'll place the card in this video above. And I'll also place the link down in the description to that video below. These are just a strip of these Dupont pins. I just need 2 of them, so I'll just bend them off of here. Now I'm going to prepare to put one of these pins on one of the red wires from the motor. All I need to do is clamp it onto the wire. Now that I have both ends with the Dupont pins, now I just need to insert them into the plastic Dupont connector in order to connect the motor to the circuit. Now I'll just twist the wires in order to keep things a little bit neat. And I'll insert the pins into the plastic connector. Now you can see that it's easy to connect and disconnect the motor at the pins. And these pins are connected in parallel to the diodes, just as the schematic shows the motors in parallel with the diodes. Now I need to move on to the other motor that has the blue wires. I'll just trim the blue wired motor now. I'll strip the ends of the wire of the motor. Next, I'll put a Dupont connector on this motor's wires. And we're going to do the same process as I did for the red wired motor by placing the Dupont connector on so that I can connect and disconnect the motor to the circuit. Here's a closer look at the plastic Dupont connector here. we just slide the pins into the plastic connector. You slide them in until you hear a click, and then I tug on it a couple of times to make sure that the wire is not going to come out and everything is secure. Now I'm able to connect and disconnect both of my motors. I can flip around the connection on the pins in order to change the rotation of my motors at any time I want to with ease. So adding Dupont connectors to the circuit really makes things much easier when it comes to connecting and disconnecting the motors. So this is the end of part 1. I encourage you to watch part 2, where we are going to place our circuit and motors onto the body of the Scrubberbot and finish up the Scrubberbot. So I hope to see you in part 2. Thanks for watching.